What is recursion? Turns out there's a light bulb joke that gives a good summary. How many turns does it take to screw in a light bulb? If it's already screwed in, then 0. Else, make 1 turn, ask me again, and add 1 to my answer. So that does a great job of summarizing the 2 key concepts of recursion. One is that you have at least 1 base case. In this case, it's the 0 turns when it's already screwed in. And 2 is you call yourself again with a simpler version of the problem. In this case, you made the 1 turn, so you're 1 step closer to the solution, and then you call yourself again. So what can go wrong? Well, the obvious thing is, say it's a broken socket and the bulb is going to just spin forever in the socket and never be fully turned in. Then you never reach your base case. This particular one will go on forever. And that does happen pretty commonly in recursion as you're debugging. So let's use a different example. Let's change tacks to a different example. Let's say that you're looking for how many boats are in X square miles of the ocean. And let's say in that space you have a yacht that has 2 jet skis on it. You have a fishing boat, and in the fishing boat there's a little boy who's holding a toy boat. And let's say you have a rubber dinghy with 1 person. So we can easily do the math in our head where the yacht counts as 3 because there's the yacht itself plus the 2 jet skis. So there's the fishing boat holding the boy who's holding a boat. So that counts as 2 because you have the boat itself, you have the boy, and you have the toy boat. That counts as 2, so you're up to 5. And you have the rubber dinghy, so that makes 6. So let's look at that as a tree. So here you have the yacht with the 2 jet skis. Here you have the fishing boat with the toy boat, and here you have the rubber dinghy. It's very common to represent this as a tree for the purposes of additional computations. But a couple of points we can make here is, as we were saying, you have recursion, and what you do is you find your first boat, so you find the yacht, and then once you're here, you can say, okay, any other boats on board this yacht? And you find 2 more, the 2 jet skis. Say, okay, we're done, we don't see any more here. Now we pop back up and we go find our second boat, the fishing boat. You look in the boat and you say, any more boats inside here? Yes, you find the toy boat. Finally, you pop up and you hit the dinghy. So what I've just walked you through is a depth first search where you are going all the way to the bottom in each boat that you find. You search the entire boat looking for any other boats within it. The alternative is the breadth first search, where you find the yacht. You say, okay, I found the first thing floating on the ocean. You don't look inside it. You just pop back up and you find, okay, I found the fishing boat. Okay, I found the dinghy. And that you've covered the whole breadth of the ocean, your area of it. And once you have your breadth, you go back and start looking deeper. You look 1 level deeper across all the boats. Now, different problems have different, whether or not you're going to search depth first or breadth first depends on your problem. Say you're doing Google Maps and you're trying to find the fastest way to your destination. You're going to do a breadth first search because that will get you to your shortest destination the fastest. In this analogy, so you could use this same tree to illustrate that analogy. Let's say that you can, this would be the shortest route to your destination. This is also your destination, but it's a longer route. So you want to do breadth first in that case because you find your shortest route first before you looked all the details of the long routes you don't care about anyway. So going back to let's talk about infinite recursion. One final concept is the infinite recursion, and we'll go back to our boat analogy for that. So for that, Imagine that you have a cruise ship in your search space. And in that cruise ship, you have a gift shop. And in the gift shop, there's a toy boat. So in a hypothetical world, let's imagine that you have infinitely precise manufacturing. And the toy boat inside the gift shop, in the toy boat, you also have a gift shop. And in that gift shop, inside the toy boat, you have a toy boat. And you would go deeper and deeper and deeper into this infinitely precisely manufactured toy and never find an answer, because there's always one more boat, one level deeper. I know it's a little abstract, but it is another analogy for infinite recursion. Thank you.